Hello, Proviso students, and welcome to the notes on how to write a quadratic expression in factored forms if you know the zeros or roots of that quadratic. So please recall that if we take two quantities, and when we multiply them together and you get a product of 0, that is if I have some quantity A times B and the result of that multiplication is a product of 0, then that will occur when we have 0 times some value or quantity B, because anything times 0 is 0, or, so that's where A could equal 0, or we could have A be some value or quantity, and B will be 0. So any number times 0 will give you also 0, so B could also equal 0. So when you have a product of 0, then one or more of the factors has to equal 0. So with that being said, let's look at this expression. We have the quantity 4x minus 5 times the quantity x plus 3 equals 0. Well, that will only be true when we have 0 times some number. That will equal 0. Or when we have some number times 0. That will equal a number. So the question is, what would make 4x minus 5 equal 0? Or what will make x plus 3 equal 0? And then you solve this algebraically. Let's look at this first factor. Add 5 to both sides. Divide by 4. X would be 5/4. That's one solution. And then the other solution, you subtract 3 from both sides, you get x equals -3. So here are the two possible solutions, or here are the two solutions for that'll make this statement true. We're going to use this fact and kind of work backwards. So instead of being given that information, what we're going to do is we're going to take this information of these roots and write it work backwards so we get it into factored form. All right, so what we're going to do with example 1 is I'm going to rewrite this in factored form, and then we're going to use a quadratic formula to find the zeros, and then we're going to work backwards, so to say, to get the zeros. So if I want to rewrite this in factored form, it is going to be the quantity x minus 1 times the quantity x minus 5. And that's just what it is. Now, let's look at it by finding the zeros by using quadratic formula. So x squared minus 6x plus 5. And whenever we use the quadratic formula, your quadratic has to equal 0. So we got that. So I'm going to figure out what the coefficients for a, b, and c are in this problem. A is the coefficient from x squared, which is invisible 1. B is the coefficient from x to the first, which is -6. And c is a constant, which is 5. Quadratic formula is x equals opposite b plus or minus square root b squared minus 4ac all over 2a. So I'm going to do this quickly and try to do it small so it fits on the screen. Opposite of -6 is positive 6, plus or minus square root. And once again, what I'm going to substitute in, I'm going to put in parentheses. So so now the radicand is b squared, so it'll be -6 inside parentheses there, minus 4 times a times c, all over 2 times a. So now I get 6 plus or minus square root. This will be 36 minus 20 all over 2. So I get 6 plus or minus square root of 16 over 2, which is equal to 6 plus or minus 4 over 2. Now I'm going to split my zeros into 2. We get 6 plus 4 over 2, which would be 10 over 2, which is 5. And I get 6 minus 4 over 2, which would be 2 over 2, which is 1. So my solutions are x is equal 5, x is equal 1. Now notice over here, if I let my quadratic equal 0 in factor form, that will happen when x minus 1 is equal to 0, or when x minus 5 is equal to 0. Solve the x minus 1 equals 0. I'm going to add 1 both sides. I get x equals 1, which matches up with that. Likewise, to solve for x here, I'm going to add x 5 to both sides. Oops. So x will equal 5, which matches up with that. So it doesn't matter if it's in standard form or in factor form. When you solve the solutions, get the zeros, you will get the same values. So what we're going to do now is, if we know what the zeros are, how can we rewrite it so we get these factors, so we're able to rewrite our original quadratic in factored form, which will be looking like that. All right, so let's look at example number 2. We have the zeros. We are given the zeros that will make this quadratic equal 0. So what we're going to do is we're going to work backwards. And what I mean by that, and this is strictly a hypothetical, this is an example. Once again, let's say one of the factors was, 5x minus 3. So we would set that equals 0 and then solve for x. So that'd be 5x equals positive 3, because I would add 3 to both sides. Then to get the x all by itself, I would divide by 5. All right? But we don't have that situation. We have not one of our solutions or zeros equaling 3/5, but we know that one of our solutions equals negative 4/3. So what we need to do is work backwards. So looking at our example, now instead of going down this way, I'm gonna go kind of backward design. So we have something x plus some other number equaling 0, which in our example was 3/5. And once again, this is just an example. You don't need to be copying this down. I guess I should have told you this at the beginning. Just pay attention to this, please. All right, so what we want to do is get this equation equal to 0. So I'm going to subtract 3/5 from both sides of the equation, which means I'm going to subtract 3/5 there. So I have something times x minus 3/5 equaling 0. The last step we want to do is we don't want a fraction here. So what we're going to do is we're going to distribute or multiply both sides of this equation by the denominator of 5. And then when I distribute, I'm going to get 5x minus 5 times 3/5, and that equals 0. And these 5 and this 5 will cancel, so I get 5x minus 3 equals 0. And this factor right here is the factor we ended up with, we began with right there. So you're probably a little confused on this right now. So we're going to do some more practice on this. But it is this process where we're going to have something times x plus another number equaling, and in this case, let's try this one, negative 4/3. So what I'm going to do first, I'm going to add 4/3 to both sides of the equation. So I get something x plus 4/3 equals 0. Then I'm going to multiply both sides by 3, And then I'm going to distribute. And when I do that, I'll get 3 times x plus 3 times 4/3 equals 0. This 3 and this 3 will cancel. Leaves me 3x plus 4 equals 0. And guess what? There's one of my factors. So I could start off by rewriting this quadratic from standard form to factored form by going x would equal the quantity 3x plus 4. Now, we have one more factor we got to find. All right, example 3. Now we do not know the zeros, so we got to find the zeros. But we could use a quadratic formula, which you have demonstrated proficiency in, so this should be relatively easy. So my equation is 3x squared minus 1x minus 2 is equal to 0. Once again, identify what a, b, and c, those coefficients values are. So there'd be 3, -1, and -2. The quadratic formula is x equals opposite b plus or minus squared b squared minus 4ac all over 2a. And now we're going to use the quadratic formula to find the zeros. So x equals opposite b would be positive 1 plus or minus square root. Once again, I'm going to substitute in parentheses for all the other variables, or I'm going to substitute in 4 values into. So b is -1, a is 3, c is -2, a is 3. So I get 1 plus or minus square root 1 minus -24 all over 6. So I get 1 plus or minus square root 25 all over 6. That'll be 1 plus or minus 5 all over 6. Now I got two solutions. So I'm going to split those roots or zeros. And I'll have 1 plus 5 over 6. And that's 6 over 6, which is 1. So that's one of my solutions. And the other one is 1 minus 5 over 6. That's -4 over 6, which reduces to -2/3. That's the other one. So now, once I got that, I'm going to find the solutions. The factors, I should say. So one factor, I got something times x plus another number equaling the factor of 1. So let's take away 1 from both sides. And you'll get something x minus 1 is equal to 0. Is there a fraction there? No, there's not. So guess what? This right here is one of your factors. So y is going to equal x minus 1. Let's find the other factor for this quadratic. So you got some number times x plus some other number, which I'm going to represent with a triangle, and that will equal -2/3. So what do I got to do? I add 2/3 to both sides. When I do that, I get something x plus 2/3 equals 0. Now I have a fraction right there. So I want to get that to be a whole value, so I'm going to multiply both sides by the denominator, and when I distribute, I'm going to get 3x plus 2 is equal to 0. Guess what? There's my other factor. So 3x plus 2. So this quadratic we have rewritten into factored form by using the zeros that we could find by using the quadratic formula. May not be the most efficient way of rewriting a standard form into factored form, but it's a way that might make more sense to you. Alright, this last problem is a U-try. Before we do that U-try, I want to do a problem just one more example before you do this. So I'm going to come over here, and let's say the solution is x equals 5 over 8. And if that's one of the zeros or solutions or roots of our quadratic function, then how do we get the factored form? I just once again want to do one more example before I get you trying doing this. You try. So we got some value times x plus another value, and that's going to equal our 0 of 5/8. But we want to make that equation equal 0, so we're going to subtract 5/8 from both sides. So when I do that, I got some value x minus 5/8, and now equals 0. And likewise, since I have an exponent, a denominator of 8, now I'm going to multiply both sides by 8, because when you do one side equation, if you do the operation on the other side, you keep everything still balanced. When I distribute, I'm going to get 8 times x minus 5, because the 8 over the 8 will cancel, and that equals 0. And right here is my factor. So let's try this with, I want you to give this you try problem a try. So pause the video, work it out, and then when you're done, play the video and compare what your work is to what I did. All right, pause the video now. All right, welcome back. I am going to work this through, and hopefully what you did would have the same results as what I'm going to do. We'll see. All right, so we're going to solve this by using quadratic formula. I got A, B, and C. A is equal to 2, B is equal to 5, and C is equal to 3. The quadratic formula is x equals opposite B plus or minus square root B squared minus 4AC all over 2A is the quadratic formula. So let's start working on this. This would be negative 5 plus or minus square root. Once again, everything I'm going to substitute in, I'm going to substitute in parentheses. Reason being, especially when you're that b squared, if you have a negative base, you need that parentheses if you're using calculator. Otherwise, a TI 34, 84, whatever will give you an answer that you do not want, but it will give you the answer that you're asking it to do. So you got to enter it correctly, and having those parentheses in there will make you do it correctly. So that's b squared 5 minus 4 times 2 times 3 all over 2 times 2. So I get negative 5 plus or minus square root 4 minus, no, that's 25, my bad. That's 5 squared. 25 minus 24 all over 4. So I get negative 5 plus or minus square root of 1 all over 4, which would be negative 5 plus or minus 1 all over 4. Once again, split our roots. So you get negative 5 plus 1 over 4. That'll be negative 4 over 4, which is negative 1. And the other one is negative 5 minus 1 over 4. That's negative 6 over 4. That reduces negative 3/2. All right, so we got our two solutions, our two zeros. Now we're going to use that to find the factored form. So I'm going to, let's set it up. Some number times x plus a different number, or could possibly be same value. Not necessarily may have to be different. But that equals negative 1. So in order to get that negative 1 equals 0, I'm going to add 1 to both sides of the equation. So when I do that, I get some number times x plus 1 is equals 0. Now I look at so now we got 0. I ask myself, are there any fractions there? No, they're not. So that is one of my factors, the quantity x plus 1. Now, let us look at the Second solution, we got some number times x plus some number equaling negative 3/2. Once again, get this part right here equals 0. Add 3/2 to both sides. So when we do that, you have that so far. And then you need to get rid of that fraction. So we're going to multiply both sides by 2. And when I distribute both sides by 2, I get 2x plus 3 equals 0. And then that gives me my other factor of 2x plus 3. And I got my answer. So that is how you can rewrite an equation in factored form if you know the zeros of your quadratic. All right, give the practice problems a try. You got questions? Ask your teacher. Bye-bye.